Good evening. Welcome to the session. We'll be starting a new topic, that is geometry. So we'll be covering the basics first, and then we'll move to the previous year's questions. So compared to other exams in UPSC, geometry questions are not so frequently asked. They can ask a lot of questions in geometry, but I don't know why they are not asking. But still, we'll go through the basics of most of the geometry topics, and then we'll start solving the questions. So I'll wait for some time for people to join. In the meanwhile, if you have any queries regarding previous topics or any other previous topics that we have completed, you can post your query in the chat section. I hope you are solving the questions after going from the session. Please solve these questions, like use the techniques that we have taught you in the class or in the sessions, and then you apply the same techniques and same concepts to solve and practice the questions also. We'll wait for another 30-40 seconds for people to join, and then we'll start the session. We'll start with today's session. So we'll cover the basic aspects, very basic part, and then we'll move to the complex part. So basic in the sense of we'll go from the points and then lines, then triangles, and then the other polygons. So we'll cover the basics first. So what is a point? A point is any dot or any mark in a line. If there are 2 points, and when you join 2 points, then this is line. This is a line, and there is the equation of a line is given by y is equal to mx plus c, where m is the slope and c is the y-intercept. So what is this m and c? So if this is a xy quadrant, so if a line is like this, the y-intercept is c here, this is c, the slope of the line is given by m. So this is the equation of the line. So if there are 2 lines, there are 3 conditions. One, both the lines are parallel. Like if they are parallel, they won't meet. And in this case, it looks. We would represent the parallel lines like this. If this is line L and this is line M, L is parallel to M. This is how we represent. The second condition is the 2 lines meet, they intersect here. So if this is an equation, y is equal to m1x plus c1, and y is equal to m2x plus c2, x plus c2. Then if they are intersecting, these 2 equations will have a common root. If they are not intersecting, then they will not have any roots. And the third aspect is in cases where the line is parallel, for example, if in this case y is equal to m1x plus c1 and y is equal to m2x plus c2. If they are parallel, m1 is equal to m2. The slopes will be equal in magnitude and in also the direct. It will be both magnitude will also be the same and the signs will also be the same. M1 will be equal to M2 if they are parallel. If they are intersecting, then they'll have a common root. If they are perpendicular, if two lines are perpendicular, that is if they are perpendicular, if they are making 90 degree, again in this case y is equal to M1 x plus C1 and this line is equal to y M2 x plus C2. In this case, M1 into M2, the slope of the line will be equal to -1. So these are the normal basic concepts of the two lines. So when the two lines are intersecting, like in this case, if two lines are intersecting, this is one line and this is another line. In this case, the angle that is making theta, if it is less than 90 degree, this is 90 degree. If this theta is less than 90 degree, then it is called acute angle. And there will be one more. If two lines are like this, same starting point, then this angle is 180 degree. And if it is greater than 180, if it is greater than 90, it is called obtuse angle. It is greater than 90. The angle is greater than 90 degree. This angle is called obtuse angle. I hope things are clear till now. If you have any doubt, you can post your query in the chat section for the parts still here, these two pages. If it's clear, please let me know. I'll move to the next part. Guys, if it's clear, please let me know. If you have any doubts, please post it. If you have no doubts, please let me know in the chat section. I'll move to the next section. So I'll move to the next section then, since nobody's replying. So there are something called supplementary angles. For example, if there is a line like this, there's one more line. This is A and this is B. A and B are supplementary angles. They are called supplementary angles, and A plus B is equal to 180 degree. So you have to remember this. A plus B is equal to 180. This is called supplementary angles. Now, if lines are intersecting, the slope will not be equal. The roots will be, it will have a common root. That's all. In this case, if it is intersecting, the roots, the slopes are not equal. Only when the lines are parallel, the roots are equal. If it is parallel, this is for parallel. Only when it is the lines are parallel, M1 is equal to M2. Okay, so this, and when two lines are intersecting like this angle, let this be x and this angle be y. X and y are equal. X is equal to y. If this is A and this is B, A is equal to B because they are diagonally opposite angles. they're opposite angles. Remember this, that if it is intersecting like this angle and this angle is same, equal, and this angle and this angle, for example, this is, if it is A and this is B, angle is B, A is equal to B. If this is X, this is Y, X is equal to Y. And if there are two parallel lines, if these two are L, M are two parallel lines, and there is one more line called transversal, let this be line N. So in this case, when these two are parallel, L is parallel to M, this angle will be equal to this angle. So let's take it as A. And these are, let this be B. So this angle would also be equal to B. This angle is equal to this angle, and B is equal to B. This angle is equal to this angle. And then this angle will also be B. This angle will also be A because it is opposite angles. And similarly here, B should be B. This will be A. I hope this is clear. And here A plus B would be equal to -180°. Common root means they will intersect at a point. If you solve these two equations, y is equal to m1x plus c1 plus y is equal to m2x plus c2, you would have one root. So x, you will have a value of x. I mean, you have a point where the point satisfies this equation also. If, for example, if there is a point, just in case, let this be AB. AB is the point. So when you put AB here, like you put B for y, A for x, and here if you put B for x2 and y, I mean B for y and A for x here, they will have same roots. They'll have common roots. X and y will have the same point because they are intersecting at a point. So this point would satisfy both the equations. This point, the intersection point, would satisfy both the equations. So I hope this is clear, this part, when it's a transversal. So these two angles are same. A and A is same, B and B is same, and A is equal to A plus B is 180°. I hope this is clear. If this is clear, I'll move to the triangles part. So whenever there is three lines intersecting, I mean three lines, you need to have three lines to form a triangle. A, B, and C be the vertices, and this is X, Y, and Z be the angle. So the property of a triangle is X plus Y plus Z is equal to 180°. The sum of the interior angles of a triangle is 180°. And if the length is A, small a, and this is B, this small c, then A plus B will be always greater than C. So this is one relation that you need to remember. This is one you need to remember. And yeah, we'll do that. And one more thing is, if you extend this line, for example, this is a triangle, this is Y, X, Z, and if this is exterior angle P, then one more relation concept is exterior angle P is equal to the sum of interior angles X plus Y, and you can derive this from this thing, from this concept, this one. So this is supplementary angles. So we know that P plus Z would be equal to 180, and x plus y plus z is equal to 180. If I substitute x for 180, if I substitute x plus y plus z, p plus z is equal to x plus y plus z. I can cancel z here. So p is equal to xy. So exterior angle is equal to the sum of two interior opposite angles. So this is the opposite angles of the interior angle z, and the opposite angles of z is x and y. And there is one more concept. It says that, like, if these are two angles A, these two are equal, and the opposite sides of these two, this and this, would be equal. So for example, if this length is L, the length of this also side will also be L. So one more property is the sides opposite to equal angles would also be equal. This is the this is one property of the triangles. And after this, I mean, till now, if you have any doubt, please let me know. Until the triangles part. So we have covered a line. We have covered the equations of line. We have covered intersecting lines. We have covered parallel lines. And we have covered the transversal. And we have covered a triangle, the length of the triangle. If A, B, and C are the lengths of the triangle, A plus B is greater than C. And one more concept is the perimeter. We'll cover it later in perimeter now. So there's one more concept called perimeter. Perimeter is nothing but it's the sum of the sides of a triangle. Perimeter of sum of sides of any polygon. In this case, it is, if this be A, B, C, the perimeter is given by A plus B plus C. This is the perimeter of the triangle. And area of the triangle is given by half into base into height. So if we consider this side, let this be A, B, C. If ABC is a triangle, if AC is considered as a base, if I draw a perpendicular from this vertex, that is B, so B's let this be BD. So BD would be the height and AC is the base. So half into AC into BD. This would be the area of the triangle. And similarly, you can draw one more now the height here. In this case, BC would be the base. So in this case, area would be half into, let this be C, or let this be P, Q, let this be P, Q, R, and this is B, D, E. This point, let this point be E, and the length be R. Again, this is area is equal to half into BC is the base, and the height is AE. And if you draw perpendicular from this vertex, and let this be F, and again the area would be equal to half into, in this case the base is AB into height is CF. So in all the three cases, the area would be the same. So area would be same here. So that's why you can say that AC into BD would be equal to BC into AE, would be equal to AB into CF. So to calculate the area of the triangle, you can take any one side and then the height of the perpendicular line from the opposite vertex, and then that would be the height. So this is the area of triangle. There are two types of special triangles. One is, if all the sides are equal, it would be called equilateral triangle. A. If all the sides are equal, then it is equilateral triangle. And in equilateral triangle, all sides will be equal to, all angles will be equal to 60 degrees. So we have all angles is equal to 60 degree, and the perimeter would be 3 times any one side. This is the perimeter, and area will be given by root 3 by 4 a square. This is the area of an equilateral triangle. This is one kind of triangle. This is equilateral triangle. Equilateral triangle. And then there is isosceles triangle. Where two sides are equal. So if this is an isosceles triangle, this side and this side would be same, and this angle and this angle would be equal. This is PQR. PQ would be equal to PR, and angle, if this is A and if this is B, angle A is equal to angle B. I hope this is clear. Till now, if you have any doubt, please let me know. If it's clear, please let me know. I'll move to the next part. Clear. If you have any doubt in this section, this part, please ask. It's clear. Please do let me know. I'll move to the next part. How area come in equilateral triangle? Okay. See, it's a standard formula. You can by heart it. If you want to derive, you can derive that also. It requires trigonometry. So don't get into that. You can actually split this equilateral triangle like this. So this would be A, and this would be A by 2. A by 2. This would be 90 degree. This is 60 degree. And this is 30 degree. This will be 30 degree. And this is 60 degree. I'll just come to this concept once I cover the concept. So let me complete this isosceles triangle, and then I'll come to the equilateral triangle area, how to calculate that. The isosceles, scalene triangle is a triangle where all this, the scalene triangle, where all the sides are unequal. They're not, all sides are different. In most of the questions, they ask about these two, equilateral triangle and isosceles triangle. And then there is third triangle, that is right angle triangle. Right angle triangle is also the favorite part of any exam. In right angle triangle, one angle would be 90 degree, and this is called hypotenuse. this is A, B, and C. We have the Pythagoras theorem where it states that AC square, the hypotenuse square, is equal to AB square plus BC square. And in the right angle triangle also, there are two types. I mean, there is two special cases. It's not two types, it's two special cases. One is where it's an isosceles right angle triangle. And these two angles are equal. And these two angles are equal, sides are equal. These two angles would also be 45, 45. And when these two, this is a special kind of right angle triangle. It's called isosceles right angle triangle. In this case, if the side is x here, the sides would be in the ratio of, if this is an isosceles triangle, the sides would be isosceles right angle triangle. The sides would be in the ratio of, like this be A, B, and C. AB is to BC is to CA. This is equal to 1 is to 1 is to root 2. Why did this come root 2 here? Because if you use this Pythagoras theorem, x square plus x square is equal to AC square. AC is equal to 2x square. AC is equal to root 2x. So the ratio of the sides would be 1 is to 1 is to root 2 if it is 45, 45. And the hypotenuse would be root 2 times the side, any one side, if these two angles are equal. This is for right angled isosceles triangle. And if there is one more triangle, which is called, in which this will be a right angle triangle, but one would be 60, 30, and 90. This is also a special kind of triangle. 60, 90, and 30, where if the side opposite the 30 degrees is x, the side opposite the 30 degree is x, then the side opposite the 60 degree would be root 3x, and the hypotenuse is 2x. So even here, if the sides are A, B, C, AB is to, take it as BC here. So I'll start from the lowest angle, 30 degrees. So BC is to 60 degree opposite side is AB, and hypotenuse is AC. This is equal to 1 is to root 3 is to 2. This is one relationship between these two sides. So we know that from here, we know that this angle, this side would be root 3 times of this thing. So if we take this equilateral triangle here, so we have the same 30, 60, 90 degree. So in front of 30, there is A by 2. So in front of the 60, this will be root 3 times this side, A by 2. And this will be 2 times A. So in this case, the two triangles would be there is two isosceles triangle here, and 30, 60 triangles here. So the area of this triangle, triangle 1 and triangle 2, the area of this triangle is half into A by 2 plus this one is root 3 by 2. A by 2, this is 1 is to root 3. Yeah, this is root 3 by 2 into A. And if I multiply this into 2, I'll get the area of the whole triangle. and this is a by 4 plus half into base into, I'm sorry, I have not multiplied the height here. So this is both the triangles are equal. And the area of both the triangles are equal. In this case, this is half into base is a by 2. Height would be root 3 by 2 into a. This is the area of one triangle. If you multiply by this into 2, you would get the triangle of area of the whole triangle ABC. And this will be equal to 2 and 2 cancels. This is a square root 3 by 4. This is the area of an equilateral triangle. That's what I have told here. Say area of an equilateral triangle is root 3 by 4a square, and area of any triangle, normal triangle, is root of 1 by 2 base into height. And perimeter would be the sum of these sides. So you don't have to worry about any other formulas here. If you stick to basics, normally UPSC is not asking difficult questions from or complex questions from geometry. In CDS and NDA, they ask complex questions from geometry. We'll see what type of question that which UPSC is asking. If till now everything is clear, we'll move to the next polygon. If there is any doubt, please ask. If things are clear, please let me know. We'll start parallelogram. Okay. See, what is parallelogram? If two sides, if it's a 4 sides polygon, and if in which two sides are parallel and equal. So if these two sides are equal, this side line, this side, okay. So if this side is parallel to this side is parallel to this side, and the opposite sides are, and this side is A, this side is A, this is B, and this is B. This is called a parallelogram. And the area and this thing, if you draw a perpendicular from this vertex to this base, this will be the height. So the area of parallelogram is given by area is equal to base into height. This is a parallelogram. In parallelogram, opposite sides would be parallel and the opposite sides will be equal, and opposite angles will also be equal. This angle will be equal to this angle, this angle will be equal to this angle. So you just have to remember this: these opposite sides are equal, opposite angles are equal, and opposite sides are parallel. And the area of the parallelogram is area A is equal to B into height. That is base. So this is B is this base. This into the height. And a special type of parallelogram is rectangle. In a rectangle is a special parallelogram where the opposite sides are equal and parallel, but the opposite angles are also equal and are equal, but they are equal to 90 degree. Thus all sides are equal to 90 degree. This is a rectangle. So just let this be the breadth and let this be the length. This is a rectangle. The perimeter of a rectangle is equal to, this is L, B, this is L and B. So we can say that L plus B plus again L plus B is equal to 2L plus 2B. This can be written as 2 into L plus, sorry, this is B, 2 into L plus B. So we can directly write this, or this is I just wanted to show how it came here. So perimeter is 2 into L plus B, and the area of the rectangle is given by the formula length into breadth. Here its length is L, B is breadth. If you multiply this two, you will get the area of rectangle. And there is one more concept here that is called, the line is called diagonal, and let this be D. And diagonal here, if you see, this is a right angle triangle. Let this be A or P, Q, R, S. If PQRS is a rectangle, QS is the diagonal. Diagonal means a line joining two opposite vertices. This is diagonal, and the length of the diagonal is given by D is equal to root of L square plus B square. L is the length and B is the breadth. So D is equal to root of L square plus B square. So please remember these things in rectangle. Once this is done, we'll move to the special type of rectangle, that is the square. Square is also a rectangle, so don't forget that. Because the sides of the square is parallel. A square is nothing but a polygon where all the four sides are equal. This is A, and A. All the four sides are equal and parallel, and the opposite angles are equal to, and all the angles are also equal, and they are equal to 90 degrees. This would be a square. And here perimeter is equal to 4 times A, that is equal to A plus A plus A. I am adding the length of the sides here, 1, 2, 3, 4, 4 times A. This is A plus A, this is equal to 4A, and the area of the square, A square, is equal to A square. And the diagonal of a square is equal to root of A. Sorry, root 2A. Root 2 into A. How did this come? This is from this Pythagoras theorem. Again, diagonal square is equal to A square. This is the side, plus A square. This is equal to 2A square. D is equal to root of 2A square. This is equal to root 2 into A. The diagonal would be equal to root 2 into A. If there is any doubt till here, please ask. So I hope this is clear. There is one more concept here. It says that the maximum area of a rectangle, the maximum area of a rectangle. So if they have given a rectangle with a fixed perimeter, they have given a rectangle with a fixed perimeter. For example, let's take the perimeter B. For example, let's take the perimeter B 40. So if we know that the perimeter is 40 meters, like the rectangle's perimeter means so this length plus this length plus this length plus this length if it is given that it is a rectangle with 40 meters as a perimeter, if they are saying that what is the maximum area of this rectangle, it will reach the maximum only when it is a square. This is one property, important property that you have to remember. If it is square, then this 40 would be, all sides would be equal. So if it's A, and A, so 4A would be 40 and A would be 10. So when the area would be maximum, when every side is, if given that the perimeter is 40, then every side is 10. So for a given rectangle with a fixed perimeter, the rectangle with the maximum area is a square. And the corollary is the minimum perimeter. If they have said that they have given a area, that they have given a fixed rectangle with a fixed area, the area with a minimum perimeter is a square. So if they have given a fixed perimeter here, then to maximize the area, we have to consider a square. Only when it is a square can the area be maximum. And if they have given a rectangle and with a fixed area, then we have to, and to make the minimum perimeter would be the square. I mean, at that time, if they have given, for example, in the same case, I mean, if they have given an area of 100 meters square, and if they have given a rectangle with an area of 100 meters square, the minimum perimeter that we can create, a rectangle with the least perimeter, would be a square. Would be a square where each side is equal, 10, 10, 10 and 10. In this case, the minimum perimeter would be 40. So I can construct the same rectangle with the same thing. What you can say, area. For example, if I create another rectangle, I can create another rectangle with the same area. What I can do is I'll take this as 20 and 5. So L into B would be 100. Again, L into B, the area is L into B, that is equal to 100. But in this case, the perimeter would be 2 into L plus B, is equal to 2 into 20 plus 5 is equal to 2 into 25 is equal to 50. So, but the least is 40. I hope this is clear. Or I can take another triangle. I can see that. I mean, if I take 100 as 4 into 25, this is 25 and this is 4. The area would again be the same, 100 meter square. But here the perimeter would be 2 into 25 plus 4. So 2 into 29. This is 58. See, the least perimeter would come when it is a square. And here the least area would be, sorry, the maximum area would be a square. If they have given a fixed perimeter, and if they're asked to calculate the maximum area, that would be for a square. I hope this is understood. If it is understood, we'll move to the next part. If you have any doubt, please ask. So we'll take up the further polygons. So we'll see a little bit about the property of polygons. What is polygon? A polygon is a diagram with multiple sides. So triangle is a polygon with 3 sides, and rectangle is a polygon with 4 sides, and a pentagon is a polygon with 5 sides. 1, 2, 3, 4, 5. This is a polygon, pentagon. And there is hexagon with 6 sides. So there is a formula for the interior angle of a polygon. Interior angle of any polygon. So if n is the number of sides of that polygon, then the sum of interior angles is given by n minus 2 into 180. So this is the sum of interior angles. For example, in that triangle, I had told you that the sum of interior angles is equal to 180. In triangle, and the number of sides is 3. So if you use this formula, it will be 3 minus 2 into 180. This is 1 into 180. So in this case, it is 1 into 180 is 180 degree. If it is a rectangle, the sum of interior angles would be 4 is the sides, 4 minus 2 into 180 from this formula. This is 2 into 180. This is equal to 360. So the sum of a quadrilateral or a sides of a diagram with a polygon with 4 sides is called quadrilateral. The sum of the interior angles of the quadrilateral would be 360 degree. And in case of pentagon, you have to, this is 5 minus 2 into 5 into 180. This is 3 into 180. This is equal to 540. This is 540. So once we know the interior angles, the sum of interior angles, if these polygons are regular, the polygons are regular polygons, what is a regular polygon? A regular polygon is a polygon where, for example, if it's a pentagon, all the sides would be equal, and all interior angles would also be equal, So all sides are equal and all interior angles are equal. And in that case, each interior angle, because they are regular polygons and they're all equal, in that case, each interior angle of a regular polygon with n sides is given by n minus 2 into 180 divided by n. In this case, in a triangle, the sum of interior angles we have calculated is as 180. If it is a regular triangle, then all sides would be equal. And if all sides are equal, then each interior angle would be 180 divided by 3, that is 60 degree. That is an equilateral triangle. And in pentagon, the sum of for pentagon, we have calculated the sum of the interior angles as 540. 540. So each interior angle would be 540 divided by 5. This is 108. Each interior angle here, this angle would be 108. This is the interior angle. So all these angles would be 108. And this would be called, if I extend this line, I'm sorry, this line is not perfectly straight. This angle D, this angle D is exterior angle. And the exterior angle would be 180 minus interior angle. This would be the case with any polygon, 180 minus interior angle, and interior angle you have to calculate it like this. And once you have calculated the interior angle, here in this case for the pentagon we have calculated it as 108. If we subtract this 180 minus 108, this would be 72 degree. So the exterior angle of a pentagon here D will be equal to 72 degree. And the sum would be 180 because this is a straight line and these are supplementary angles. I hope things are clear. If you have any doubts, please ask. And please do make notes also. I mean, while I'm writing, please note down in your books also these things. Are things clear? So I think today I'll have only the time for covering the basics. Tomorrow we'll start the questions. I have circles left, circles, and then I have three-dimensional objects. Once these two is completed, we'll end the session today, and then tomorrow we can have the problem solving session. Okay, we'll start the circle part. So a circle is nothing but how do you define a circle? A circle is a trajectory of points which are equidistant from a certain point. So for example, if this is the circle with a radius r and a center O. I'm sorry with the diagram here, it's not very perfect. So in this case, we have certain metrics here. The length of this circle, I mean the circumference, the formula is equal to 2 pi r, where pi can be written as 22 by 7, and the area of circle is equal to pi r square. So these are the basic things that we need to remember. And the diameter of the circle is equal to 2 into r, 2 times the radius, that is equal to d. So here circumference you could write, since you have 2 pi r, 2 into r is d, you can write it as pi d also. Excuse me. So this is the three basic things: circumference, area of circle, diameter. And if they have given a circle, and if they have given a sector here, if for example, if they have given that this angle is theta, sometimes what they'll do is they'll ask you to calculate the area of this sector or the area of this part, the circumference of this length, this part. So how do we calculate this? We know that this whole angle is 360. This whole angle is 360. So this area of sector, let this be O, A, B. So O, A, B, the sector O, A, B area is equal to theta divided by 360 into the whole area of the circle, that is by r square. This is the area of a sector. Remember this. And then if they ask the length of AB, just the AB, not the whole sector, just the length of AB. So AB would be equal to theta divided by 360 into 2 pi r. This is the formula for that A into B. So how is this? This is by the fractions. The whole thing is 360. Out of that, theta is only for this sector. So it's like, for example, if theta is 90, if this will be a circle and theta is 90 degree, so this is the 1/4 of the circle. So theta is 90 divided by 360 into the area of circle. This is 90 and 94 is equal to 1/4 into A. So this is how, this is the area of sector and the area of this length segment AB. If things are clear, this AB is also called arc. The other name is arc. Arc AB is the length, just the length here, this length. And the area of this sector is this whole thing. I hope this is clear. So if we have, there's one more property of a circle. So if there are two, if there is an arc AB, so if AB subtends an angle here on the circumference, if this is, let this be a point C. If this angle is theta and this is the center of circle, this angle would be twice the theta. This is one property that you have to remember. So if this is this angle that it subtends at the circumference, if it is theta, so this angle by the same arc that is subtended at the center would be twice that this. So this is 2 theta and this is theta. So remember this. And from this we get, this is a circle and this is the diameter. Diameter is a line that passes through a chord which passes through the center of the circle. But what is a chord? Chord is a line that touches 2 points in a circle. This is a chord. And a chord that crosses the circle of center of the circle is called diameter. This is called diameter. And if diameter is like if you draw a line on the circle like this, another line like this is a diameter. This is 90 degree. This angle is 90. How it is 90? From this. So this, if let A and B be the arc here. So AB is an arc which subtends an angle 90. If it is subtending an angle 90 at the circumference, at the center this would be 180, twice the angle 180. So don't worry, we'll keep this video public itself, even after this class. You can make notes. If you have missed, you can make notes out of this. I think, is this clear till now? So I'll just give a recap of the things that we have covered from the starting. Okay. So if 2 points are joined by a line, I mean, if 2 points are joined, we have a line, and the equation of a line is given by y is equal to mx plus c, where m is the slope of the line, c is the intercept, and there are like 3 conditions where one where both the lines are parallel. When both the lines are parallel, the intercept, the slope of the lines would be equal. M1 is equal to M2, and these are parallel lines. When they are intersecting, y is equal to M1 x plus c, y is equal to M2 x plus c. They'll have a root here. I mean, there will be one point which will satisfy both the equations of the line. Can you see the video? Please let me know if the videos are clear.